Hello everyone. This is my first video lecture about nanotechnology. On the left side, there is written series 1. Series is the subject name. Series 2 will be the next subject of the biosciences once this subject is completed. Nanoscience or nanotechnology. Nanoscience or nanotechnology are the same terminology, have the same meaning. And make we deal with the study of nanoparticles, nanomaterials, or nanocrystals. In this video, I want to cover these 5 topics. Nanomaterials. Nanoscience is an intersection of chemistry, physics, material science, biology, engineering, and many other disciplines to study metals at nanometer scale. More specifically, this multidisciplinary field is focused on metals with at least one dimension size from 1 to 100 nanometer. This sometimes means that those objects which have a size range from 1 nanometer to 100 nanometer, from 1 nanometer to 100 nanometer are called nanoparticles or nanomaterials. Nanomaterials therefore refer to the class of materials with at least one of the dimensions in the nanometric range. Here it is history and the scope of nanomaterials. The word nano, a Greek prefix meaning dwarf, or something very small, 1 billionth of a unit, that is 1 to 100 nanometer. This is the nanometric range. How small is a nanocrystal or nanoparticles in materials? A nanometer represents a dimension about a few tens of thousand times thinner than the human hair. One human hair thickness is about 80,000 nanometer to 100,000 nanometer. Guys, the diameter of a human hair is very large. When we compare with the objects having a size of 1 to 100 nanometers, means nanoparticles. The world of small dimensions. On the left side there is a number, on the right side there are name and symbol. 0.1, as you know, that represents DC, represented by D. 0.01 centi C. 0.01 millimeter, that is small m. 0.000 blah 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 micromolar nano. Different objects from macro scale to nanoscale. In the case of micromaterials, the grain size is typically of the order of 1 to 100 microns. 1 micron is equal to 10 to the power minus 6 meter. Nanocrystalline materials have a grain size of the order of 1 to 100 nanometer and are therefore 100 to 1000 times smaller than the conventional grain dimension. However, compared to the size of an atom 0.2 to 0.4 nanometer in the diameter, nanocrystalline grains are still significantly big. Different objects from micro scale to nanoscale. On the left side, there is a single-walled carbon nanotube that has a diameter of 1 nanometer. It is 100,000 times smaller than the strand of a single strand of hair, that is 100 micrometers, having a diameter. And in comparison, on the other side there is a house which have 10 meters wide. So this shows the comparison of nano-sized objects, micrometers, and a size having a diameter and the size and the range of meters. 1 nanometer is equal to 10 to the power 9 minus 9 meter, that is 0.000001 meter. 1 divided by billion, that is equal to 10 angstrom. Nanomaterials may have different characteristics and properties as their size is getting smaller or larger. Nanomaterials can be metals, metal oxides, and composites. Nanomaterials are not new. So nanomaterials are very old, but the concept is very old. But this field is now an emerging field, which have played a very prominent role in the area of research, whether it is on the chemistry side, physics side, or biology side. Nanomaterials have been produced and used by humans for hundreds of years. However, the understanding of certain materials as a nanostructural material is relatively recent, made possible by the advent of made possible by the advent of advanced tools that are capable of resolving information at nanoscale. For example, carbon black is a structured material that is used in the car tires to increase the life of the tire and impart black color. Another example is steel. You know that steel is an alloy. Alloy is a combination of two things. That is iron or carbon. Is believed to have been first prepared in India about 1500 years ago for making strong and sharp swords that easily cut a helmet into two pieces. Very recently, a high-resolution electron microscopy of such a steel that have been picked up from a museum showed that presence of carbon nanotubes in them, which has surprised scientists. The high strength of these steels may be due to the presence of these carbon nanotubes. How we can visualize nanomaterials? The development of advanced microscopic analysis techniques, including transmission electron microscope, atomic force microscope, uh, these are the techniques through which we can visualize, we can see, we can judge, we can see, we can observe the particles. Not only these two techniques are used for the identification and characterization of materials and correlation of their behavior with the structures, but there is also UV electron microscopy, UV spectroscopy, FTR, Fourier transform infrared microscopy. So there are different types of techniques that are used for the visualization, for the observation of human materials to identify and characterize them. So thank you so much for watching this video, guys. In the next video I will come with the new video in which I will describe you the classification of nanomaterials. So thank you so much, guys.